All right, we're back. We're on page 4 of notes 11 of Calc C. We're integrating powers of trig functions, and we're just going to go for it and see what we can do. So we're in, every technique we've talked about, maybe some additional ones we didn't talk about in these videos, but that you've known for years. Who knows? Let's see what we can do. I see an odd power of sine, so I'm going to save one sine. Sine squared, cosine squared, and I'm saving sine. Look at me not putting parentheses. Oh my God, such a rebel. I hate that. I hate when there's no parentheses, but also it's so annoying to write them on these problems. So what are you gonna do? All right, sine squared. So I'm saving sine, so everything else becomes cosines. 1 minus cosine squared. And then I put them in cosine. Let's just be inconsistent. That's murder. That's so bad. All right, we're gonna let u equal cosine. Big advocate of actually doing the u substitution on these because there's just too much going on. Negative 1 minus u squared du, negative integral u squared minus u to the fourth. And again, slow down the video or speed it up or jump ahead or whatever you want to do. All right, I'm going to integrate and substitute cosine cubed plus 1/5 cosine to the 5th. I'll maybe at the end of the video try to check these. It's you end up wrestling with your calculator so much that I don't know. All right, I see I have an even sine but an odd cosine. Save one cosine. Sine to the 4th. Cosine to the 6th. Oh man, this is gonna be. All right, so sine to the 4th. This is gonna be 1 minus sine squared cubed, right? Because it's cosine squared cubed. And then cosine dx, u equal sine. This, you basically have to. Then du, I mean, you don't have to, but you're not cubing that out without a substitution, I hope. I got u to the 4th, 1 minus u squared cubed du. All right, here we go. Integral u to the 4th. So it's 1, 3, 3, 1 are the coefficients, and then so it's going to be 1. Then it's minus 3 u squared plus 3 u to the 4th minus u to the 6th du. 1, 3, 3, 1, right? So it's a 1, a 3, a 3, and a 1. And then a is 1, so you go 1 cubed, 1 squared, 1 to the 1st, 1 to the 0. And then b is negative u squared, right? No, negative u squared. So you go b to the 0, b to the 1st, b to the 2nd, b to the 3rd, and b is negative u squared. So that's why you're getting that alternating there. Some people memorize 2 different formulas, one for positive, a plus b cubed, and one for a minus b cubed. No need. Waste of time. All right, distributing. Maybe also a waste of time if you're on your, if you're on it, but I'm doing it. Right, du. All right, integrate, substitute at the same time. U is sine of x, so 1/5 sine to the 5th minus 3/7 sine to the 7th. Do you run into this problem in the real world? I don't know. 1/3 sine to the 9th of x, and then minus 1/11. It's for every purely academic exercise, I feel there's someone sitting somewhere who's I use that all the time. All right, I think that's it. I don't really know. I mean, really discomforting that one's simplified, but it did. So nothing we could do. All right, keep going. All even powers. Gross. If it's all even powers, there's nothing to save. Power reduce. So this is going to be the integral of, so it's 1 plus cosine of 2x over 2, right? That's this is this. And then times 1 minus cosine of 2x over 2, and then squared, because sine squared squared, and sine squared is the thing that we replace. So this, well, all of this is this. And then there's still a dx. Nice. All right, so you have to like multiply this out. So I'm gonna, like u is gonna be cosine squared, cosine of 2x. I'm trying to think like what's the fastest way to do this. I'm gonna do like an extra problem on the side here. I'm gonna do so I'm gonna do 1 plus u times 1 minus u squared, right? Because that's essentially what we're gonna have. And there'll be a 1/8 because of 1/2 and then 1/2 squared. So 1/8. So I'm gonna multiply these, but I'm gonna do this in a weird way. I'm gonna multiply 1 plus u and 1 minus u to get 1 minus u squared, and multiply that by 1 minus u. So this is gonna be 1 minus u squared minus u plus u cubed. So 1 minus u squared plus u cubed. That's weird. Is that right? 1 minus u squared minus u plus u cubed. Okay, I guess so. So at this point, we have 1/8 the integral. Let's just say u equals cosine of 2x. So I'm not integrating yet. Like I'm just rewriting this thing. Which, oh no, I can't even do that. Oh crud. All right, so let's not do that. We're going back to the cosine squareds. So I'm gonna have 1 minus cosine squared of 2x, which is like sort of a problem, and then minus cosine of 2x, which I can integrate, and then plus cosine cubed of 2x. Are you seeing this? We have to do like every technique. All right, so 1/8, that's fun. We definitely get just like x, right? So that's, I'm gonna run out of colors here. This gives me this. That part's done, yay. Cosine squared, unfortunately, so it's gonna be minus 1/8 the integral of cosine squared. I'm gonna change into 1 plus cosine of 4x over 2 dx. So as I mentioned, I think I'm gonna run out of colors to highlight with. So this became this, and that's a problem that we need to solve. I don't know what color I'm even using anymore. All right, so it's minus 1/8, and then 1/2 sine of 2x, because I can actually integrate that. So that is from this. That 1/8 is killing me. And then cosine cubed, odd power of cosine. I'm going to save a cosine. And then, yeah, so this will be plus 1/8 the integral of cosine squared is 1 minus sine squared of 2x. And then I saved a cosine of 2x dx. Gosh, what a opportunity to practice everything that we've done, you know? That's the name of the game. So good for us. So this became this. That highlighting is awful. Okay. So what? Let's just start doing things, I guess. I got 1/8 x. Now I got minus 1/16 x, because I'm just like integrating as I go. So the 1/2, this 1/2 and this 1/8 gave me minus 1/8, and then I integrated 1 to get minus 1/16 x. Then I have minus 1/16. I'm going to pick up a 1/4, so that's 1 over 64. So minus 1 over 64 sine of 4x. Okay, that's that part. I guess, do I keep highlighting? I don't even know. I don't know how to highlight this. So like all of this came from this, I guess. I think that's the way to highlight that. This is already minus 1/16 sine of 2x. Boy, I hope I get this right. And then when I don't, like, I don't know. So that was, yeah, that's this. And then this, we have to integrate again. So the integral of cosine of 2x is 1/2 sine of 2x. So there's going to be plus 1/16 sine of 2x. That's from distribute. I distributed this and integrated it, and then times 1/8. And then 1/8. So minus 1/8 times minus 1/24. Minus, what am I doing? Minus 1/8. Okay, hold on here. There's a 1/8, basically. I need a 1/2, that's 1/16. Then I need a 1/3, that's 1/48 sine cubed of 2x. Showing more work makes this easier. And I didn't do that. So, you know, this, I believe, is this. So, shall we see? Well, what happened here? We have a situation where this and this have canceled out, so that's nice. And then also 2/16 minus 1/16 is 1/16 x. Minus 1/64 sine of 4x. I don't know how I'm going to check this. And then the sine of these things canceled. And then minus 1/48. Because like I cannot imagine what the calculator is going to spit out as the answer to this. Like double angle formulas everywhere. Anyway, I'll check it at the end in a second. Oh my God, what a joy. This problem is like, oh my God, -1/6 cosine to the 6 of x plus c. Are you kidding me? All right, so that, yes. Let's check these. So one of these was a real doozy. And who even knows about the previous ones? So calculator, I'm going to just see integral of sine of x cubed cosine of x squared dx. Oh my God, I don't know. Let's take the derivative of our answer. I don't know. Let me just Trig expand that answer. It's that's not like super helpful. Well, like if I factor that, no, I don't know. What is it even doing? Oh, it's getting a common denominator. And I don't want to deal with that. Let's take the derivative of our answer. Derivative, -1/3 cosine of x cubed plus. It's like, sometimes you just have to have faith in yourself because checking these is so annoying. Oh my God, t collect. What are we gonna do here? I think let's define f of x. This is not gonna go well no matter what I do, I'm thinking at this point. Let's say f of x is this. And then because I'm gonna graph that. So that's my answer. And then what did the calculator get for the integral? Integral, let's say that that's g of x. And let's just graph them. This is like a good way of checking. Well, sort of. I mean, they appear to overlap. The problem is, I don't know, like what, do they overlap? Sure, maybe. That's like same. All right, we're calling it. That one's good. New problem, because clearly these are going to be annoying. All right, so let's just define no way. What can we do here? How about this? Let's do the integral. I'm gonna like fake check. The integral of u to the fourth 1 minus u squared. Because I think it's just as interesting to work out how to like check as it is to do anything else. Oh my god, expand that. Okay, minus 1/11 to the 11th, 1/3 to the 9th, negative 3/7, and then to the 7th, 1/5 to the 5th. I'm gonna say that we got that right because just let u equal sine of x, and that's like what we got. I mean, do you want to see what the calculator says the answer is? Sure you do. Integral sine of x to the fourth cosine of x u to the 7th, comma x. Oh, expand. It does like all the trig identities. There's like no good way to check that one. I'm not checking it. New problem. Let's see. So for this one, I will try, I think, integral of cosine of x squared. I should just define cosine and sine as like a and b, and then I can just do like a squared b whatever to the fourth, but didn't. Let's collect that. I don't know. T-collect. Expand that. No, don't expand. Do expand. I don't know. Expand. So 1/16th, that's good. 1/64th, and then 4x. I have that, and then I also have this extra part. All right, we're going to define that as that, and then g of x is x over 16. I mean, like, so this is silly. I really only need to check like the part that differs, which I'm pretty sure is just doing like, I don't really know. I think it's using sine. I don't know. How do you get up there? Like, how do you get up to 6x? Somehow. Sine of 2x cubed. Or was I supposed to do that? I don't think so. Graph and f of x. G of x. They're either the same or they're so similar. And if they're only like so similar, I don't know. Look at that. Yeah, that. I think that's good. Okay, so that's. I sort of think that graphing is your best chance. Evaluating at points is probably also like a super good idea. This one, I don't know. I don't know if it's gonna do what we did. I feel like it should because this is pretty straightforward. Yes. Woo! All right. So that one checked out for sure. I am going to go back to the notes. So we got them all right, which I think is like crazy good. All right. So hopefully you just did these on your own and you're just like scrolling through this video and like all of my discussion was basically for nothing. But if you watched the whole thing, thank you because this was a lot of work. And I'll be back in the next one to do the next page. So see you there.